All right, how's everybody doing? Good? Can you hear me okay? Volume good? Okay, great. So, we are moving on to do 7.2. Of course, everything that we have here is cumulative. So, all the rules from 7.1 are going to be in play till the end of the semester. So keep up on those rules too. We'll be using them obviously in the homework, but also on the tests. Before we get started, any questions, anything you want to go over before I cover the new rules? Okay, cool. So let's just really quickly look at the new rules. And I'll explain in terms of the English meaning what they mean. So the first one is Constructive Dilemma, or CD. And the point of this one is, if you have two conditionals, two if-then statements, let's just say you have square, then triangle, and circle, then, what's another shape? Crap. What is this? Is that trapezoid? Anybody remember any nerds? Yeah, trapezoid, okay. Nerd. So we've got square, then triangle, circle, then trapezoid, and then we have square or trapezoid. We can conclude from that triangle or trapezoid. I'm trusting you that that's a trapezoid as I say it for the recording over and over again. Okay, the reason why this works is because, again, this is saying two things are true in one. Two things are true. Square would, if it was true, give me triangle. Circle would, if it was true, give me trapezoid. Well, I know at least one of them are true, right? I'm going to have square or trapezoid or maybe both. So I'm going to fulfill at least one of these sufficient conditions, right? That means I'm going to have at least one of the consequence.
Would it be square or circle?
Oh, I'm sorry. Yep, you're right. My bad. I got trapezoids on the brain.
Oh, no.
Wait, what am I doing? Oh my god. Now I've got circles on the brain. Okay, yeah, thank you. So, yeah, okay, again, let me re-explain that without my mistake. You've got at least one of the sufficient conditions. Maybe you have both of the sufficient conditions, but you have at least one. Well, if you have something that's sufficient, you're going to have the consequent of that, right? So you're going to have at least one of the consequence. Does that make sense why this is a valid way of arguing? Questions about it at all? Okay, again, if anybody's in doubt that these are valid inferences, you can always put them in a truth table or ask me to do it. All right, next rule we've got is the Rule of Simps. Let's say we have square and triangle. I can conclude from that square. I can also conclude from that on a separate line triangle. I'm just breaking it apart and asserting each part. Because all this means is that square is true and triangle is true. I could just say square is true. Or I could say triangle is true.
It makes sense to me exactly what you just said, but in the book for some reason it was only saying you can take the left one.
This one?
Yeah, it was saying you can only take square out of that.
Yeah, so that, for some reason, that, did it explicitly say that, or was it just how the formula was written?
Yeah, it said you can only take the left.
Okay, yeah, just ignore that. Because
It makes sense.
that makes no sense. What they're trying to get you to do, there's a rule later that says if you have square and triangle, that's the same thing as triangle and square. So they're trying to get you to, oh, you only get what's on the left, right? So you have square down here. But what if I want triangle? I have to swap the order, then get triangle. What? That does not need to be a rule, right? Like, who cares? Yeah, so just ignore, if the book tells you something like that, and it's clearly the meaning of this, you can get both. Go with the logical meaning, right? Because again, the rule set for each of these logic books that use this propositional logic, the rules are going to change. There's different ways to formulate the rules. So that's kind of all arbitrary and subjective anyway. But the core system is going to stay the same. Any other questions on simp? And I will be calling it simp for the rest of the semester. Okay, conjunction. Another simple one. If I have square and I have triangle on two separate lines, that just means they're both true, right? Well, if they're both true, then I can also just conclude from that in one statement that they're both true. Right, I think I talked about this early on in the semester. I can list off a bunch of things that are true. I like cats, I like dogs, I like pizza, I have gas. Or I could just say it all in one big proposition. I like cats, and I like dogs, and I like pizza, and I have gas, right? That's all conjunction is doing. Make sense? Okay. Give myself more room. What's the last one? Addition. This one is a little bit more complicated. Not really complicated, but it's harder to see why this works immediately. Let's say I have square. From anything square, I can conclude square or triangle, where triangle is whatever I want it to be. Does anybody know why that works? Can anybody explain that?
Because at least one of them is true.
Because at least one of them is true, right? So the truth condition of this is that you have at least one. Well, if I start with knowing I have one of them, I have square, I can just say anything as ridiculous as I want to and add it to it with an or. And I know whatever I add is going to be true because I already know I have at least one, right? It's just a little technicality that helps you solve some of these problems. So if I was going to give an English example, I could say cats are mammals. Therefore, cats are mammals, or pizza is sentient, right? We know pizza is not sentient, at least I hope so. I'd be guilty of genocide. But we know cats are mammals, so even though this statement itself is ridiculous, it's technically true, right? Does that make sense? Okay. Remember, the or is an extremely weak operator. It does not say very much. Okay. Questions, comments, anything about the rules?
For addition, is or the only operator you can use?
Yes. Yeah. So for any of these rules, the operator that is in the diagram of the rules is only that one. Yeah. There are some of them where it works on multiple operators that we'll learn later. Like, I can't remember what that one's called, where you switch the order. If I have square and triangle, square or triangle, both of these are just the same thing as that, right? Does that make sense? So for some of the rules we'll learn later, they work for multiple, but for basically everything we're learning now, just that one type of operator. Carson, do you have a question?
No, I was just looking through the rules again.
Okay, cool. All right.
I do. Back to CD.
Mm-hmm.
You said I made that mistake on here, but does it have to be, it can't just be square then triangle and then square or O. It has to have an and. Is that correct?
So let's say, I'm not exactly sure what you're asking. You have to somewhere have something of both of these format to combine them. Yeah. You have to have something like one or two to combine. But you can have, if this is what you're asking, like say I have on line 9 and 10 of my proof, I have those, right?
Yeah. So that would be
That wouldn't work yet. What do I have to do to get them like this?
combine them.
Combine them with a conjunction, yeah. So once I combine them with a conjunction,
Then you can go back in with 11, 10.
exactly.
CD. Okay.
9, 10 conjunction, 12, now, yeah, then I'd do my CD from that. From that and something that looks like this. Does that make sense?
Yeah. Please don't erase that.
Yeah. Here, I'll give you this on 8. Square or circle. And then I would conclude from that 8, 11, CD, triangle or trapezoid. All right. Everybody good on what these rules mean, why they work in terms of English or the common ways we think? Any last questions?
I just hate the additional one because it's just too easy.
Yeah, it does feel easy, right?
Like
The addition one is really critical for some of the technicalities of logic, because if that's true, right? If the addition rule works, and let's just say we have not P, right? Well, we can add to it P, and we've got ourselves what's starting to look like a little contradiction. But there's some paradoxes and stuff that result from some of these technical rules that it's taken people a long time to figure out exactly how to make a system of logic that doesn't have these paradoxes. Yeah. And so we get some of the weird rules from that sort of thing. All right, you good on this one? Okay. So let's just work on some homework. We'll start with the rapid fire stuff on the rules. We'll just go through the first few. Let me write them down real quick. All right, if I have these two right here, they just want me to draw the conclusion using this rule. Jillian.
B, and then 2 simple.
Good. 2 sim. What else can I simplify?
What else can you what?
What else can I get from the simplification? I can get one more thing out of it. Yeah.
Or is that?
Is that what you said?
Yeah, I couldn't tell if it was a G or an E on 2.
Yeah. My writing's bad today. Yeah. Yeah, you get B and E from that. Okay, good. And then, what about this one? Who wants to take this one? How can I use a constructive dilemma here?
I'll try. Is it 1, 3? A,
Yeah.
not N?
So A or not N. 1, 3, constructive dilemma. Good. There's one more thing you can use a constructive dilemma on. It just might not look like it. Anybody see it?
3, 4. Right? No.
No, because, so for the constructive dilemma, you have to have the sufficient.
Not D or S.
Good. Not D or S. From 2, 1, constructive dilemma. Now, it might not look like it, again, because 2 is like out of order, right? But the order doesn't matter, right? It's just, think in terms of having the content there. You want the content. It doesn't really matter how it's written that much, what order it's written in, so long as you have that information there that you could pull out. Okay, these make sense? Okay, let's just get right into proofs. I think we're doing pretty good on these. let's see, where are we at in the homework? Have we started doing the proofs in this section yet? Okay. Let's, what's the highest number you've been up to?
I haven't started on 7.2 yet.
Okay, that's fine, yeah. So let's do 7.2.3. Let's go, Carson, you'll take 1. You'll take 5. Remember your number. So 1, 5. Jillian, you've got 6. Halfway. How far are you?
15.
You take, yeah, let's do 15. You take 15. Samantha, how far are you?
15.
Okay. You take 14. Okay. 1, 5, 6, 15, 14. Yeah. And if you need a second to do them, take that time. But if you're already done with them and you want to come up and start working on one on the board, you're more than welcome to. Whatever you need to do.
I mean, 5 is the only one that I sort of halfway got through. I mean, I was just confused on it, so I don't.
That's good. You want to come up and do 5 with me right now? All right. Copy 5 down, and then we'll get started with this bad boy.
7.2.3.
7.2.3, yeah. Okay, G, then S and T. S or T, then, is that J? Yeah, J. G, therefore J.
So I know that you can get S and then T. So my question was, could you split these up, get S, get T, and then could you take those two different propositions and can you combine it like that?
You can't combine it. You can only combine with a conjunction, which is an and. But you're close, so go ahead and break it apart. Okay, so now looking just at the meaning, look at 2, right? Thinking in terms of meaning here. If you have S or T, if at least one of them are true, then you've got J, right? Is at least one of those true?
Yes.
Right, so you know that you can get J. Now it's just a matter of how do I write this in accordance with the rules?
That's where I was tripping out.
Yeah, so there's 2 things you can do. Both of them using the same rule. So on 5, you could use what rule to add something to it? Addition, yeah. I gave it away right there. Yeah, addition. So you can just add T to S. Even though you already have it. Yeah, you just use the addition rule.
So I was thinking combining these two, in reality I should have just added one together.
Yeah.
And then I would
Good.
say 5, 6 addition.
No, you just said 5 add, yeah.
My bad, sorry.
Now you could do the same thing if you chose to do it with 6, right? With T you can add an S, doesn't matter.
Sorry.
Good. Beautiful. Okay, yeah, there you go. You got it. Good job. Okay, we can just leave that one up. So what was throwing you off is, you know, if you can see the meanings here, if you've got S or T, and you know that means at least one, and you've got S down here, you should just be able to conclude J. right? That would be nice if you had a shortcut like that, because in terms of the meaning, that's a valid inference. Does that make sense why? So we could, if you want, you could formulate a new rule 1, right? We could say, if you have something like S or T, then J, and you have S, then you can conclude J. Or if you have S or T, then J, and you have T, you can conclude J. We could have an infinite number of rules like this, right? The problem is, where would it stop, right? We could do this for an infinite number of propositional forms, right? But that's right. So the point in saying this is, once you get comfortable with logic, you don't have to exactly follow the rules in the book. Even if you're comfortable in this class, and you're thinking in terms of meaning, like on a test or homework or something, if you give me a skip like that, totally fine with it. Maybe ideally what you'd say is 1, 2, conjunction plus modus ponens. So you're doing what's called a double call, if that makes sense. But if anybody is comfortable with this type of stuff and wants to kind of skip, that's totally fine to do that type of thing. Does that make sense?
Yeah, I just didn't know I could do that.
Yeah. But again, like that, this double call stuff is not in the book, right? But the book is just a nice, useful guide. A starting point, if you will. All right, who's next? Who wants to go next? Come on. What number did you have again?
6.
6.
And I have one question before we start.
Yeah.
Because I did this on the other homework, but I just changed it all because I don't think so. Can you do, so like on this one, I have 1, 3 bonus points. Can you do that if you have something like that? Because I know it's,
Mm-hmm.
so you
So
can't,
yeah, if
even
you
though it
have
has
L or
2.
T, then you can get the right-hand side, yeah.
Okay, well then I guess both my answers would be right, but I'll just do the new one.
Cool.
Oh, wait a second.
Might be, might not be, who knows? Let's see it. I like how you've all internalized the double slash. Even though the book has a single one, I always write a double one, so I can see that I've brainwashed you. I don't know why I do the double slash, it's just a habit. Good, good. Yeah, that looks right. Did anybody see a problem with that? Oh wait, hold on, wait. Constructive dilemma 1-4. Yep, that's step 5. Step 5 is the one that's wrong. Everything else would be correct if 5 was correct.
Okay, so hold on.
What was the other way you did it? Yeah, so on 5 you can't do a constructive dilemma on 1 because you just have one arrow. You need 2 arrows joined together by an and for a CD. If you look at premise 1, does that make sense?
I thought the book showed it with one arrow. Am I not correct?
Mm-mm. Yeah, no, it's something like P then Q and R then S. P or R, therefore Q or S.
Nope, that's not it. Oh, hold on. Because you couldn't do that. That's why I went back and changed that.
Yeah.
Because you couldn't do it. So there is.
So starting from, we can just start from your last one. If you want to erase everything 5 and later, those first 2 moves are correct. And your moves after 5 are correct too, following the rules.
Okay, so 5 would be.
Yep. Yeah, good.
And then
Good, good, good. Beautiful. Right, okay, there you go. Yeah, does anybody see a mistake that I'm not catching there? Okay, yeah, that's completely correct. Yeah, good. Nice. See, you're getting there. No room for discouragement here. Okay. Who wants to go next? Come on up. Did you have
I said one.
one? Okay.
Yeah.
I didn't want to overwhelm you if you hadn't started the homework yet. But if you want to pick another one, you're totally fine too.
Tried 19 too. I don't know if I've got it right or not.
You want to try? You want to do 19?
Sure.
I'm imagining one's pretty easy, but
Let me grab my book.
you use that. Yeah. It's okay. You can erase whatever you want to erase to get more room.
which number is this?
19.
Not really. That's what. So I started out and I got a 4 for not O. For simplification.
Good.
Then I used the not O to get not P by using 5, 3 or 3, 5 modus tollens to get it is P.
Yeah. It would be not P or P,
Yeah.
whatever you want to put. It doesn't matter. Again,
Yeah, well, I
technically.
mean, you can either do that or you have to use double negation.
Right, yeah, and we don't have double negation yet, do we? I don't think so. Yeah, see, that's what the books sometimes frustrate me. It's like you shouldn't need a separate rule to do double negation, you know? But yeah, whatever you want to do. You can put P, you can put not P, I don't care.
And then I turned around and used 2, 4, or no, 2, 5 modus ponens to get U. Oh, right, wrong number. And then I combined the U and the not P with conjunction, so it'd be 6, 7. And then I got Q
Nice.
with 1, 8 modus ponens.
Good, 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 good. Beautiful. Yeah, good job. Okay, great. Yeah, good. I like it. I like what I'm seeing. We're all doing good. This is good. Any questions on this one? Okay, who's next? Out of you two. Samantha? What number did you have again?
14.
14. When I was an undergrad taking this class from the same book, I mean, it's literally the same class as at UCO down in Edmond. I just basically ripped off the entire class because I thought it was so good. Like, even down to like the homework problems we do, the book we use, everything. I took this class just like I'm teaching it now, and I really appreciated how good at logic I got from it. And then the next semester I took the advanced logic class, one step up from this, and they changed the textbook to this online textbook. It was free, which was nice, but it had this online proof software where it was like a computer program that you did this in, and if you wrote anything even just a tiny bit wrong, it would invalidate your entire proof. It would actually give you negative points, and it was like a game. You had to get to 100 points to finish the homework. So if you wrote like a negation, a space, and then a P, it would count that as wrong, and it would give you like negative 20 points. So you'd just be doing the homework for hours and hours. Because if you made one mistake, it would set you back like an entire problem or two worth of points. But I was thinking, like, it would be awesome if there was a good computer program that allowed you to do proofs like this with our rules, and just so you could quickly be doing it and learning the rules. I'd love if somebody could make that.
Yeah, because there's not even anywhere online where you can check it.
No, yeah, there's nowhere.
Back when we were doing truth tables, I had to withdraw from my class, but my first semester here, I took like an Excel class. That was years ago, but you could probably write an Excel software that can do a truth table in seconds.
Yeah, I don't know how to use Excel at all.
No, me neither.
Yeah. I would imagine like the truth functional stuff with truth tables would be pretty easy. Though my wife's really good at Excel. Maybe I'll have her do something. Okay, so let's walk through this one now that you're completed. So premise 4F from 3 simplification, good. 5, 1, 4 most exponents, good. 6, 5 simplification, not T, good. 6 add, beautiful. 2, 7 modus ponens, beautiful. 9, not H, modus tollens, from good. Yeah, perfect, that's great. Nice handwriting too.
Thanks.
All right, let's see what you got. Good. 4 active. 6 S or K. 1, 5 minus opponents. Beautiful. Good. Nice. Good. Okay, great. Yeah, perfect. Very concise. I don't think there was a single extraneous step there. Good. Any questions on this one? Okay, cool. I like what I'm seeing. I like every single one of you has shown improvement and has gotten quicker at this, so that's really good. What time is it? We still have plenty of time. Does anybody want to do some more? Are you feeling good? How are you feeling? Okay, how about this? For whoever thinks you would rather go do other things, and you're comfortable enough with this stuff already, you're free to go, no judgment. For anybody who wants to stay and do some more, I'll run through a few more. So if you're good, I'll see you later. And if you want to stay, great. Raise your hand real quick. Who's going to stay? Okay, cool. Let's assign a few more proofs to you three then. See ya. All right, let's do 18, 17. Which one didn't I have them do? Did I have them do 14, 15?
We did.
16.
That one's in the book.
Oh, you want to do 18,
I'm gonna actually
17?
try. What about, did we do 12?
Okay, yeah, let's do 12. I don't think we did 12. Okay, so 12, 17, 18?
I have the book, but it's on my laptop, so can I just take a picture of your
Yeah,
book?
yeah. Yeah, you can just use it. I don't need it.
Sure.
Yeah. I don't have to do any of the work. I've done my time. Good. Good.
Sorry.
Perfect. Yeah, exactly. Good job. Good. You did it, see? See? no reason for discouragement.
I don't think I've ever cried in a class before. No.
It's okay. I mean, I've said it before, but I said the same thing when I took mathematical logic. I don't think I've ever cried about a class.
I think I got it figured out how I'm gonna do it, so.
Cool. It's like logic and math are just one of those things that if you don't get it,
Well, I'm
like
good
if
at
you don't
math.
get it immediately, it's just like so frustrating.
Yes, but I'm good at math, and I should have went to school for math, but I don't want to be that kind of teacher. I like history.
That kind of
teacher.
teacher.
Though I will say my 8th grade math teacher was the biggest pothead in the world.
Really?
But
That sounds fun.
yeah, I'll stick with history.
Yeah. Do you want to teach like public school, or what do you want to do?
College.
College, cool. So you're gonna go to like grad school after this?
Yep, I'm looking at Keene University and Westchester University.
Cool.
I want to do their Holocaust and Genocide Studies program.
That's cool.
And then, I don't know yet for a doctorate. We'll get there.
Yeah.
If we get there.
One step at a time.
Yeah. I'm just ready to get out of Oklahoma.
Oh, me too. Trust me.
So I'm just praying, saying a little prayer, good juju, whatever it is out there, that they accept me. I don't want to stay here any longer. I graduate next semester, so
Yeah.
I'm almost there.
How many schools are you gonna apply to?
I'm gonna just do those 2 and then here, which even if I got accepted here, I don't think I'd take it.
Yeah. Makes sense. I completely get it.
I'll just work. I'm a hairstylist also, and I haven't worked in a few years, but if I have to go back to do that until I get accepted, I'll do it. I won't work public school, especially here.
Yeah.
Native American studies isn't my thing.
So we got 5, not H4 simplification. Good. Yeah, no, my wife, this is her 7th year teaching school in Oklahoma.
Public?
Yeah, and she's at a charter school now, like online, because of COVID. But, man, it was
I don't like kids.
horrible. Really?
I like my kids, but I don't like kids, and there's too many emotions in middle school.
Go be a teacher.
I want to be a professor.
Oh.
Yeah.
I want to be with people who actually want to be there for the most part.
Oh, rude awakening.
I was like,
It doesn't change.
there may be a problem.
Yeah. I'd say 70% of my students do not want to be here. This class is different because it's upper level, and like, you all chose to take it, but like, my God. You see my other logic classes, it's like, I can't even get them to do the homework.
Really?
Yeah, like, we're about to be on proofs, and some of them aren't, like, have not started the truth table section. So, it's crazy. But yeah, no, I completely get it.
And then in high school, they're shooting everybody, so I don't want to be there either.
Yep. It's kind of crazy that you have to think about that now. One, 5. Good. Good conjunction. I like your symbols. Nice. Okay, good job. Great. And again, bonus points for using my notation. Yeah, that's perfect.
Good deal.
So I was talking about Excel program back when I was an engineering major.
On your step 6, does that say 2?
What made you convert from an
Yeah.
engineering major?
I'm horrible at math.
That will do it.
Which one?
Either one.
Will you not erase his? You can erase mine.
One on the left, yeah.
So now I'm the second major, and it's actually called the primacy principle. If you learn a thing, and there are multiple options to the thing, whichever option you learn first splitting the horseshoe from the book, so it took a really long time for me to switch to the arrow.
Yep, it makes sense. I mean, I learned the arrow first, and I will never switch to the horseshoe. I can't do it.
It's just whatever you learn first.
That's funny.
Yeah, this is a big one, it might take a while. That should be in and you, right?
3 M and U, yeah.
That's also how most of us do that too.
Yep, exactly. I don't know how I started doing that. But it's so funny that it's influenced everybody.
Which I guess that's a good thing, that means it's paying attention.
Yeah, exactly. It's seeping in on some level.
I think by having two, it doesn't confuse you as being another like bracket or anything.
Right, I think it's more, I think I started doing it because I would do these long problems and it's just more decisive like that, you know.
So this right here, I'm kind of iffy. Can I do that?
Yeah, yeah, you can just add anything you want to a, yeah.
I'm always conditioned to think if it's too good to be true, it's.
I know. Yeah, no, I mean, that add rule is really just like a nasty little trick. It's like, it lets you get away with so much.
It just feels cheap.
Yeah. But then when you actually understand it, it's like, okay, yeah, it makes sense, it's right. It's just like, yeah, it feels cheap in terms of like, when I'm trying to solve the puzzle of these problems, I can just add whatever I want and get it, and it's like, that feels weird.
Like if you're doing like an actual physical puzzle, that feels like stamping your own piece.
Right, exactly. That's a good way to put it, stamping it on a piece. Okay, simp, good. Good, okay, good job, yep, valid. Unless we forget, the whole point of doing this is to show the argument's valid, even though we never say it or write it. So yeah, okay, good. That's great, we all did it correctly. Okay, what time is it now? 11:19. Everybody want to do more? You feeling good? It's up to you. I mean, as long as we cover the material, I don't have to keep you here.
This was symbolic logic, but if memory serves me right, if you have say if you have E and not E in the same one, you could basically infer whatever. Because you can add to not E, and then you can prove the other one correct by using, I remember what rule that is.
So if I had a contradiction like E here and not E here,
Yeah.
and then what were you saying I could do?
If memory serves me right, you could add whatever you wanted. Like you could add something to E using addition,
Right.
and then make whatever that is you just inferred correct with when you use regular E or
Yeah.
not E.
Let's
Either
say I want to prove I do that with a 1 addition. Come on, microphone. So I just add this big thing, J and K to E, yeah. And then 4, now I could just do a disjunctive syllogism, right?
Yeah.
Because I have not E here. I go 2, 3, disjunctive syllogism, I'm left with J and K. So yeah, I just cheated and proved it, right? That's the problem with having contradictions in your premises, where this is technically valid, right? So you have to have, we have the restriction or the criteria of validity, we have soundness. In inductive arguments, we have strength and cogency, like probability. And we have, for deductive arguments, we have valid, we have sound. Those are two, in a sense, restrictions on the arguments that we should think are good. We also have to put the other contradiction, or another restriction that says a good argument can never have a contradiction in the premises. Because from a contradiction, yeah, you can derive anything you want. And that's caused people historically, when developing systems of logic, a lot of problems. How to restrict that. Now, the notion of soundness does actually rule this out. How would that work? How would the notion of soundness prevent you from having contradictory premises? Remember, the valid is if the premises are true, the conclusion will be guaranteed, right?
Yeah.
Sound is valid plus what?
They're all true.
All true premises. Could these premises ever be all true? Oh. So soundness itself kind of involves a restriction here. Yeah. But it also helps to spell it out explicitly. Yeah. But yeah, it is interesting.
Yeah, I think we had like a couple of proofs in logic and critical thinking that was like one way that we used to get the conclusion.
Yeah. Yeah, I think it does eventually give you a couple problems with that, yeah. I'm wondering if my test bank has any of those. That'd be fun.
Have the grades been, speaking of tests, have the grades been released yet for the last one?
For test 1 or test 2? No, I haven't gotten test 2 yet. Yeah, I'm still grading test 1 from one of my other classes. So it's going to be, I'll start grading test 2 for this class. I'll start grading it probably Thursday, once I finish test 1 for my last class. It's just constantly rolling, a rolling grading. All right, Jillian.
On 7.2.1, number 8, it's just on premise 1 it's E and G, and then on premise 2 it's blank, blank, and add. So does that mean I can just add whatever I want to it, and that's the answer they're looking for?
Yeah, so if I had E and G, what could I add to that?
Anything.
Anything, right?
So that's, okay, I was just making sure that was correct.
Yeah.
So one add, so it could be E and G or, yeah, X, Y. Or whatever that is.
Do something crazy like this, right? Just anything you want, literally. Yeah.
It just seemed too easy.
So I have a question.
Yeah.
So for 7.2.3, number 10, there's a big whole process. But basically, this comes from the conclusion not being in the premises at all.
Okay.
So what you do, because that was one of the ones that it solved for me. So what it did is it basically just broke it down to one statement, which that was D, and then it added D or M, and it just disproved D.
So D or E, then G and H, G then not D, D and F, therefore M.
It makes sense what they did, it just feels so cheap.
Right. Okay, so walk me through what they did again. So we've got D and F. I'm just going to simplify these.
Yeah, that's what they did the first time. They got D or E.
So D, F. What was the next thing?
And then after D or E, they use that to get G and H by one of those ones.
So yeah, you add D or E together for add.
After G and H, they got G.
Yeah, simplifying G. 1 minus Conan's 9.
And they just did D or M.
Oh, okay, yeah. So,
It's the same thing we just talked about.
Yeah, it's just a covert contradiction in here, right? Because if I have G, I get not D.
Yeah. Well, they did D or M, and they disproved D, and then obviously by disjunctive syllogism that means M, but
Yeah, right.
So I can just add the conclusion even if it's nowhere in the premises too.
Right, yeah, because technically this is valid, right? I mean, it follows step by step. Every single thing we've done, every rule of inference has been good. So it's valid. But it's always going to be unsound, right? So it is cheap. Like, you don't want to argue this way, right? Because you do have the contradiction D and not D. Yeah, but yeah, I mean,
So anytime the conclusion is nowhere in the premises, the way you would do that is by creating some type of disjunctive syllogism and somehow disproving one side.
I'm trying to think if that's going to be a universal rule. Every time the conclusion is not in the premises, do you have to do some sort of disjunctive syllogism and have a contradiction? So basically, from a contradiction, create a disjunctive syllogism and then disprove one side of it to get the answer. That sounds right to me, but I'm worried that I'm not thinking of some sort of exception to that rule. Because there could be an exception somewhere. Like,
If the OR operator is the only one you can use for addition, and that's the only way that you can introduce new parts, then I guess that's true.
yeah. Yeah, I think that would have to be true. I can't think off the top of my head of a way you would do it without that, though. Well, it depends what you mean. If I have a conclusion that says not D, and then somewhere up here I don't have a not D, then I can obviously, without doing something cheap like that, get a not D, right? Does that make sense? So if I just have D up here, like let's say D then Q, and then Q I have not Q, I can get not D from that, right?
Yeah.
Most don't. So that's technically not D is nowhere in the premises, but D is.
Yeah.
So that rule would have to be more accurate to say, if the letter itself, that proposition's not anywhere in the premises, right? Then then you would have to do something tricky like that. And I don't think a hypothetical or we haven't learned it yet. I don't know actually if we do learn it fully. There's two techniques for doing proofs that let you make assumptions. Oh, I guess you could. Say I have in my conclusion M then R. And I have up here that's complicated. Okay, there is technically a way you can do it without doing that cheap thing. I'd have to think of a problem to illustrate it. It's hard to do it off the top of my head. There's two methods of proof where you basically assume that something is true and see what follows from it. And at the end of that assumption, you basically go, oh, well, I assumed this thing and got this thing, so I can conclude this, then this. Assumption, then whatever I derived. That way you can probably technically get something that's not in the premises, some letter, by making an assumption. But that's a different technique that we haven't learned, yeah. So, for the most part, you're correct. Unless you do something pretty complicated, yeah.
Can we do 9?
9.
Or me do 9?
Yeah, you want to come up and do it?
Oh. Sure.
Let's try it. Yeah, you can head out if you want. 9. Yeah, see ya. You heading out too, Carson?
Yeah.
Cool. Yeah, you're good. I'll see you guys later. Take it easy. Okay, that's good.
And this is where I get stuck. I know I need to use 6 and 3 somehow,
Mm-hmm.
but what can I use? I can't use conjunction, can I?
So let's think in terms of meaning, right?
Terms of
So
what?
meaning.
Okay.
So let's think through this like meaning wise. So you've got T then R, and that means which one's a sufficient and which one's necessary condition.
You have, if you have T, then you have R.
Right. So T is sufficient for R,
Mm-hmm.
and R is necessary for T.
Yes.
So if you have not R on 3,
Mm-hmm.
well, you don't have what's necessary for T, right?
Right.
So
Simplify?
how? Simplify, exactly.
Okay.
See, once you start thinking about the meaning, then it all starts coming out, yeah.
And then that would be minus empty.
Mm-hmm. Empty.
That'd be 6, 7, T, and that would make, sorry, not T, correct?
Mm-hmm.
Okay. So I got that and that. I can't add 4 and 8 because that'll give me or, but I can do conjunction.
Conjunction,
So 4,
beautiful.
8. So why does this make more sense to me than just the MP, MT, but I can use those?
I have no idea. I have no idea. Something about your psychology just latched onto these rules better. I don't know what it is.
Okay. So, just weird. Alright,
Yeah, good job. Okay, so now there's one more way to solve this.
okay.
So you see how on 8 you got not T?
Mm-hmm.
You already had not T, didn't you, right?
Yeah,
You're completely correct.
okay.
I was thinking of doing the problem when you put it up the exact same way. But then I realized, well, wait a minute. If I started this over, right, I can do a simplification just like you did. Well, I can simplify this, right? I can just simplify straight from 3, not T, and then I can just conjoin it.
That make it a lot quicker.
Yeah. And so it's like, yeah, some of them are tricky because it's like they give you something like this, but then we start thinking in this longer way. This is, again, completely correct in exactly how I did it in my head.
Okay.
And then I realized later, oh, wait a minute, like, yeah, there's literally 2 steps in the conclusion. Yeah, so multiple ways to do things.
Okay,
Cool. Good job.
thank you.
Progress.
Yeah, I can't believe it.
Goodbye, everybody.